So, have you ever had this thing happen where you're just casually listening to a bunch of music on YouTube, and a bunch of it's okay, and suddenly there's this one video that's labeled the A to D version of that song? And it starts playing, and at first glance you're like, oh, okay, this is pretty interesting. It's like some spatial audio. If you're wearing headphones, it's like, okay, we have some aspect of sound. And then at second glance you're like, wait, what the hell is this? This is just like a mono audio source that's like being moved, like being panned left and right. What is this? And then suddenly it ruins all your taste, and then you spend the next day figuring out how this works and getting the software so you can do your own little experiments. Well, that's kind of what happened to me. So in this video we're going to talk about what is this 8D, I'm going to call it nonsense that's on YouTube, and these videos seem to be getting millions of views. The reason I ended up on that playlist that I was listening is because apparently had more views than the actual song. What? These videos are getting millions of views. So let's talk about what is this trend with this 8D audio. Let's talk about how it's done. Let's talk about how you can create it, and I'll even show you the demos. I'll show you how to set up the software, how you can make your own versions of this, and then maybe in this video, maybe in the next video, I'll talk about how you can actually spatial audio done right, or how can we actually take advantage of the psychoacoustic platform to create virtual surround sound to be a little bit more useful, to be a little bit more interactive than just this mono audio source moving around. So let's get started. Alright, so what is this 8D audio stuff? Okay, well, first of all, from a geometric standpoint, we live in 3-dimensional or 4-dimensional if you consider time, space, or space-time. So first of all, this 8D is obviously just a marketing gimmick. But let's set the marketing gimmicks aside and let's focus on the technical details for now. So if you've listened to a couple of these videos, and there are remarkably a lot of them, there are entire channels dedicated to making these 8D versions of songs, you will probably have noticed a few trends. At first glance, as I mentioned, it does actually sound like it is virtual surround sound. But at second glance, it sounds like it's just a single audio source that's being virtually moved around. And that's because that's exactly what this is. All the common surround videos that I've seen for music are actually just taking the stereo song, converting it to mono so that they can get a single point source, and using a psychoacoustic platform to move that in 2-dimensional space. So let's talk about psychoacoustics for a second. We have 2 ears. This means that we can hear stuff in stereo, right? So historically, for surround sound, our brains have adapted to being able to tell whether sounds are in front or behind us given these two sources. And that's because of all the weird shapes in your ear, so on and so forth, where sound entering from one dimension is going to reflect and bounce and sound differently than sound entering from another dimension, right? So sound coming from the front of you will sound different from something behind you. And that's because it's like your bass and treble, all your frequencies will be slightly offset by how it bounces and how it interacts with your ear and inside of your ear. So our brain has a way to hear what's front and behind us. Now, we do actually have a bunch of binaural recordings, and they are freakishly real. There's a very popular door knock one, and there's also the very popular barbershop one. I'll link those in the description below because they're very interesting. If you have headphones, especially open back headphones, go give them a listen. It's actually fascinating going through it and figuring how it works. So when you're done this video, go watch one of those. It'll probably be worth it. If you've never heard these before, it's a pretty interesting experience. So how are those done? Essentially, we want something that mimics the way we hear. So how you would do that is you literally have a dummy head with ears on it that are shaped very similarly to ours, and then you just put a microphone in it. That way, whether it sounds behind or front of you, it'll bounce and reflect in the same way that it does in our ear, except instead of going to an eardrum, which will vibrate, convert it to liquid, convert it to solid, so on and so forth, and then signal it to your brain, we have a microphone that will take that air vibration, convert it to an electrical signal, and then we can then play back the electrical signal to create an air pressure, so on and so forth. You get my point. So you can get binaural audio. It is a thing. Essentially, you just have to take the ears, and instead of eardrums, put microphones in it, and then there you go. It works. Any recording done on those, you'll be able to tell if it's in the front or behind you pretty well. Now, there's also the second way to get surround sound, and that's the obvious one. Have actual surround speakers set up around you. Very common in home theater setups, very common in the movie theater. For example, for 7.1 surround sound, you'd have 2 speakers in the front, 2 in the back, 2 on the sides, a center channel, and a subwoofer. So that's 6 for front, side, back, your center, and then the 0.1 is for your subwoofer. 0.2 would make it 2 subwoofers. Same with 5.1, you'd have front, rear, center, and subwoofer, right? So we can actually reproduce spatial audio by literally placing speakers around you. Now that's traditional 5.1, 7.1 surround sound. There's also all the new stuff with like Dolby Atmos. Instead of encoding the audio as just 7.1 channels, we encode it as a parameter, so it's like, oh, it's here in space, and then it's up to your receiver, which, depending on how many speakers you have, to interpret that and then reproduce it in such a way. But in this video I want to talk about psychoacoustics. So that is where we have taken this audio source and made it sound like it is coming from all around us, or from a particular point. Without having multiple speakers set up, we're just using headphones with 2 speakers, and without recording it with like a dummy head. We don't have that binaural audio recording. We have started with a regular mono or stereo recording, and we want to make it sound like it's different places in space. So how do we do this? Completely relying on how we interpret our hearing, right? We have to take the 2 speakers that we have and make it sound like all around us. And the most common way we've actually determined this is a couple professors and other companies have done what are called impulse recordings. So that is where you would actually set up your head and then just play an impulse sound from a bunch of different directions. Then we record the sound that we hear, and then that gives us what's called an impulse. Impulse recordings are very common to reproduce stuff like a reverb, right? If you have a particular environment, you just record a loud song like a clap or something, and how it sounds over time. You create what's called that impulse recording, and then when you're at home, you can make anything sound like it's the reverb in that exact same room. I can take my music and apply reverb with that impulse recording and make it sound like that music was being played in that room. So it's a very similar thing. We've done it once in a laboratory where we've actually positioned speakers or whatever all around a person and done a sound, recorded those samples, and now we can use those samples to modify our own regular music in the same way, because we know that whatever like white noise or whatever noise it was, how that got changed, whether it was in front or behind you, if we change our music in the same way that that was changed, we will be able to reproduce that effect. So that's how this works. Now about those 8D videos. So as I said in the second dive, what they have done is taken a stereo song, down-mixed it to a single mono channel, and then what all they're doing is using a psychoacoustic program to position that mono source around you. And so you can just, any program can treat it as a point source, and given an impulse recording, you can modify that point source to be where it is in space. So for example, let me demonstrate this. I played the Fat Rat's time-lapse at the start of this video. Let me actually show you how this looks in a program. I'm going to try it with the mono version of the song, and unlike that, let's play this for a little bit longer, and let me move this mono point source around so you can hear how it sounds. You're going to need headphones to get the full effect of this. Alright, so now that you've heard that, you see how this works. That sounds pretty much identical to what you would see in those videos, and that's because it basically is. Now, let me show you how you can create these. So we're going to use a couple things. The program I'm using for this is called SoundScapeRenderer. I'll have a link in the description down below. Their code is freely available on GitHub. It's a free and open source program. Now, SSR only works with a jack. It does not work with Pulse Audio or ALSA natively. So you'll also need to set up jack, and I'll maybe have this in a second video about. So you'll need to install jack on your computer. What jack does is jack is essentially, it is very similar to Pulse Audio in that it lets you have many sound devices playing. It's a sound server, and it'll take all of those playing from the clients, mix it, and then send it over to ALSA or OSS, whichever you're using to actually run your sound card. So in our case, we need to take the output of this program in jack, convert it, and then send it to our sound card to be played. So here's how we're going to do this. Now, there are also a few limitations of SSR. One of these is that it only works at the sample rate that the Jack server is running at. This is actually a common error that you might encounter, and there are over 5 GitHub issues on it, and it took me a while to debug. Essentially, if you try launching SSR, there's a very decent chance that you will get an error that does something along the lines of the sample rate is expected to be 44,100, but is 48,000, or vice versa. Basically, the impulse recordings that they ship with SSR are recorded at 44,100 Hz, which is fine. Except, that means that your Jack server needs to be running at 44,100 Hz as its sampling rate. The problem is, most sound cards only support 48,000. I tried a Creative Sound Blaster SP0410. I also tried a pair of Sennheiser PXC550s with a built-in DAC. And I also tried the motherboard's onboard audio. None of these could actually set the sample rate to 44,100. All of them, except the motherboard onboard, got stuck at 48,000. In this case, fear not, we can actually still do this. We just need to convert that impulse recording file from 44,100 to 48,000. You can check what sample rate, by the way, your Jack server is running at if you launch QJackCTL. In QJackCTL, it'll tell you what the sample rate is currently set to. So, whatever that's set to, we need to resample the impulse recording to match it. So here's how we do it. Well, my first attempt was let's just chuck it into FFmpeg and give it -AR 48,000, and obviously that didn't work because the impulse recording has 80 tracks and FFmpeg cannot deal with it. But our savior is SOX. SOX can resample unlimited channels in a WAV file. So we just have to run SOX, give it the input impulse recording, give it the sample rate of 48,000 or whatever it is that your Jack server is running at, and give it the output file. In my case, it happened to be in the Universal System Resources /share folder. So this meant that I had to move the old file, the original, somewhere else, and then overwrite that file. Yes, it's a bad idea to overwrite stuff in your root directory, but this one worked, so you can always change it back. Just make sure you don't delete the original. So we take the original, move it somewhere, and then run SOX, upsample it to, or downsample to whatever frequency you need, or sample rate you need to, and then we're going to save that resulting file into the directory that it's looking at. And then you'll be able to launch SSR without any problems. Another common issue on Linux systems. If you have Pulse Audio running, chances are you won't be able to run Jack unless you have the Pulse Audio plugin so Pulse Audio can output the Jack. So what you'll have to do is just run Pulse Audio -K a couple times. Make sure that the Pulse Audio process is completely not running, and then you can launch the Jack server. So you can just run that with jackd, or if you have QJackCTL, you would just launch the UE and click Start. So in QJackCTL, if you go to Options, there's also a list where you can pick your sound card and pick the sample rate. You can try a sample rate of 44,100 first. If that doesn't work, obviously just set it to 48,000. And just select the sound card that you want to use. Again, it will take over that sound card, so you won't be able to have another program playing in the background. Before you run SSR, if you're having issues, but you want to just test your Jack setup, this is very easy. Just use VLC Media Player, VLC or MPV. So if you're an MPV, just launch MPV space -AO and then just type Jack, and that will tell MPV to output the audio to Jack instead of trying to output the Pulse Audio or ALSA. So this way you can try playing a song in MPV first. Make sure that your Jack server can actually hear it and play it. A useful thing in QJackCTL is you can open the graph, and the graph has all of the incoming connections and shows you exactly how everything is piped. So when you're playing MPV, you should have MPV appear as a source, and you should be able to take MPV and connect it to your playback device, and then you should be able to hear it. You can also try with VLC. You just have to go to View and then Preferences and go to All, and then you can click on Audio and then set it to Jack instead of Pulse Audio or ALSA. Now, SoundScape Renderer has a couple of different ways with which we can use it. For example, you can use AAP if you wanted to convert to multiple speakers, but for us, what we're going to be doing is we want to use the binaural version. So what the binaural version does is it's going to take in as many of our inputs that we want, and it's going to use the psychoacoustics to end up with binaural with 2 outputs. Again, this is opposed to, you can look through the list. I will have their repo linked in the description for all the other supported modes. But for headphones, binaural is the one you want to go with, and it's also the default one. It should be A-least when you just type SSR. Now, we have a couple of parameters. If you want to run this from a command line, it's actually entirely possible to run this program from a command line without the UI. I'll launch the UI because it helps demonstrate exactly what's happening. Now, this brings up the question then, why do all these videos do this with the mono sound? Because it's just a point source moving around. Well, it's actually why. Essentially, for their gimmick, they want to just have a point source moving around. But then this brings up the question, what happens if we put more than one track? So instead of giving it the mono and positioning it in one location, can we take this and can we give it 2 tracks so that we can put 2 things in different locations? And it turns out that we can. So if you just give it the stereo version of a song, you can see that we have the 2 channels, and we can move these 2 channels independently. Then the stereo got me thinking even more. Well, instead of 2 tracks, what if I took the multi-track versions? For example, multi-track for Bohemian Rhapsody is pretty well known to be 24 tracks. There's a bunch of songs with the 16 tracks, 14, where it's essentially a bunch of the individual recordings of the instruments. What if we took that and we positioned that in the binaural audio space? Well, it turns out we can do that as well. Tracks are a little bit different than stems. And you can, I'll put a link in the description about the difference between multi-tracks and stems. For this, basically multi-tracks will give you a little bit more leeway to do what you want with it. Stems will be a little bit more restrictive, but both will work in the exact same way. But both can be used in very similar fashions. I bring this up because usually it's easier to get your hands on multi-tracks or stems. Usually they're made available for the purposes of remixing songs. You can take like one aspect of one song, combine it with another aspect of a different song. In fact, for what I'm about to show you, I got the versions of this music from remixing websites. Unfortunately, I don't think I can only play a very short snippet of this here, but I will have the entire rendered version of the song on the second channel. Hopefully it doesn't get copyright struck. I'm not planning on making any money from these videos. As long as they don't take the video down, I'm fine with if they collect the revenue or whatever. By default, the program only lets you put in one WAV file, right? And it has to be sampled at 48,000 Hertz because that's what Jack is running at. There's no resampling built in. And we also need it to be S16, signed 16-bit integers, little endian usually. Now, what we can do is, if we have the multi-tracks, we can use FFmpeg to take these individual mono or stereo tracks from each of these channels and combine them to a single multi-track file. So the command for that's pretty simple. You just go ffmpeg-I and then list all of the input files. And you can just use a single filter to take in all of these inputs and remap them to be different channels in the same file. So instead of 10 files that each have one channel in them, or a single mono recording, we're going to make one file that has 10 or 20 channels in this single file. Now we can take this newly produced WAV file and feed it into SSR. Now in SSR you will then notice that it will import each channel separately. So we can actually now position everything separately. And this is really cool because for these multi-track recordings, our vocal is separate from guitar 1, separate from guitar 2, separate from the 4 drums, separate from the bass. We get a ton of flexibility. We can position all the instruments where we want them. You can have the vocals in the front, drums here, the guitar here, put the bass like behind you, and then you can essentially listen to the song in a pretty cool surround environment. And it's unfortunate because instead of the gimmicky 8D videos, if you use psychoacoustics for this, it sounds so cool. As I said, I'll hopefully include a demo here, and I'll see what I can do. It's a neat application where instead of one track and just moving it around spatially, what we've done is we have taken all of the instruments and spatially positioned them around us. And instead of the nauseating videos where it's like a single thing moving, we can actually keep it static, like, oh, let's put all the drums here, let's put the guitar here. Now, would this be practical for listening? Probably not, because I think most songs have very good engineering and mastering, and they sound phenomenal. And they sound phenomenal in stereo. But if you want to play around with this, you can get some very interesting results. And honestly, it sounds pretty cool. I would argue that it's more than just a gimmick this time because there's actually something to the sound. You can actually feel like you're in the middle of a recording studio and you can actually hear and separate all these individual channels. If you can get your hands on a good multi-track for a song, and they are available on many different sites, won't go into it here, give it a listen. Chances are, if you position everything correctly, you will probably end up hearing something that you didn't hear in the original video. Now, here's how we can actually install SSR and get this working. So first you want to head on over to the SSR website, which is linked down below, or I'll put it on screen here. They have binaries available for most of the common Linux distributions as well as Windows and Mac. Once that's installed on Linux, we'll need to set up Jack. The easiest way to do this is ArchWiki has a great source. I'll be using Jack 2. You can also use Jack 1. They're not compatible with each other, so just keep it in mind. And then to manage Jack, I'm using QJackCTL, which is the bare bones, very common app that you use to stop the Jack server, configure interfaces. So once you have that running, and you've set the sample rate, we can then map everything. Now to record this video, here's the interesting thing. I cannot actually record, normally I just use Pulse Audio and record the monitor device, but I can't do that here. So what I've done is Jack is way more flexible than pulse audio in this regard. Unlike pulse audio, which has your typical sinks and your sources, and then everything just goes to one source, Jack can natively handle splitting audio sources, joining audio sources. So I can, essentially the reason it was called Jack is it's like a virtual patch panel. You can take the output of any program, patch it to the input of any other program. So in this video what I'm doing is I've taken aother, which is a pretty cool and free and open source digital audio workstation. Very nice software. And instead of running it in the regular ALSA mode, if you run it in Jack mode, it'll show you all of the inputs and outputs of the tracks. And now we can just take the output of this, map it to the input of that, take the output of that, map it to speakers, and there we go. That's how you can actually record the output of this. For any of those YouTube videos, people don't just run SSR. They just have the plugin, and then they will just run the plugin separately. This just lets you play around with it a lot more. And unlike those pre-packaged canned solutions, you can actually play around a lot more with the positioning and whatnot here. So once you have SSR running, we'll just launch the GUI, and then you just select the file, give it a WAV file that has all your tracks and the correct sample rate and correct bit depth, and then you can just play around with it. If you have issues, leave them in the comments. I've done a ton of debugging in Jack. I'll try to include a segment at the end of this video on how that's going to work. With that being said, thank you so much for watching this video. This video has been a bit of a while in the making. Essentially, literally, as I said in the intro, it started with me hearing one song in my YouTube playlist, and then digging deeper, and then a few days of experimentation to get all the stuff running. And trust me, SSR was not the first software I tried. I've gone through multiple different iterations of software I can use. I've literally tried everything from LATSPA modules to implementing stuff in MPV, to piping the output of VLC into programs and then running real-time effects, to recording samples in aother and trying to do surround virtualization. I've been through multiple iterations of this. This is the one that ended up working the best, and it's the one that's getting featured in this video. Just know that there's a lot more behind the scenes that happened that I unfortunately don't have time to include in this video. Now, if you want to dig deeper, I'm going to leave all the links to the stuff I talked about in the video description so you can continue researching. And if you end up doing something cool with this, please consider leaving it in the comments down below. I'd love to see what you guys turn this into. Once again, with that being said, thank you so much for watching this video. I hope you enjoyed it. If you did and you'd like to see future endeavors or of whatever crazy thing I go up to, please consider subscribing to my channel. It helps me a lot. And consider sharing this video with your friends or anyone who might be interested in weird audio processing and digital effect and signal processing situations like this. If you liked this video, please consider leaving a like. If you disliked it, you're more than welcome to dislike or consider leaving what I can improve in the comments down below. Thank you, and have a great day. Bye.